Okay, guys, let's look at the warm-up here. Let's see, R equals 3 sine. Sure, I'll just put, I have the luxury of being able to just make a polar grid on my paper. I know you guys cannot do that. Have you done the second one? No. Okay, you need a minute still? That's fine. Go ahead. I'm just writing the equation here. I'm not actually doing anything. Can't remember my equation.
I have a question. Why can't they make screens radial so that you can make straight radial lines on them?
That would be nice. What am I looking at? Yes. So the negative, there's a negative in front of the R, not in front of the theta. So you're still going in this direction where you started. Where's negative? So you just go backwards? So you start over here. Oh, I just gotta flip my thing. Yes. Throw pencils at me. You've had enough?
Yes, I get it.
It's just like flipped with the negative. Oh, sorry guys, I didn't.
Yeah. Okay. That.
So close. Okay, does cosine start at the pole or out at the end of the pedal?
At the pole. At the end of the pedal.
Yeah.
At the end of the pedal. Does start.
I'm gonna get it this time.
I started at the end of the pedal too, and I stopped myself.
Yes! Woo! We'll say third time's the charm, but I'm not sure how many times that actually.
More than 3. Definitely more than 3.
You got there though. That's good persistence. Are we close, guys? Maybe? Oh no, some are done, some are still working though. See you diligently plotting points. Okay. Yeah, that's helpful.
How did you get 4 points? How do you have 4 points? It's 3 theta. You don't double 3 thetas.
Well, even if you did, it wouldn't be 4. It's okay. All right, guys, I'm going to put the first one up here. On the first one, did you get that your first pedal would be at pi over 8? Yes? Okay. And then you can find all the rest of them. I just look at the spacing and visually do it. I think it's easier that way. Like I know it's 1.5 past the axis, so I'm going to just keep doing that. 1.5, half, and then equally space your other ones, which ends up 1.5 the other direction. Okay, so there's my 8 pedal points if I was graphing the entire thing. It is a sine graph, so does it start at the pole or out at the pedal? Pole, because sine of 0, 0. So I know I start in here. I'm going to start graphing the whole thing, and then once I get 4 pedals, I'll switch colors so you can see what the final 4 pedals would look like, because that's what your answer actually is. Does that make sense? And guys, if you want to do that on your test, if you want to graph the whole thing like in pencil and then take a highlighter or a pen of another color, something to show me like, hey, this is my actual answer, I'm fine with that. Okay, you don't have to like diligently erase the part you don't need. Okay. All right, so the order you graph them in, you start at the pole, and I come out to that first petal. Remember, we always are graphing in this counterclockwise direction. I do not connect to the one straight across, so I'm not going there, not here. Okay? I go one past that, continuing in that counterclockwise direction. So this will be my second point. And then that same process, not here, here, okay? Not here, here. You guys see it? It's a little off. Okay, that's 4 petals, so everything that's left will actually be my answer. So your answer is here. Ooh, my petals are not exactly equal, but you get the idea. So the blue is the answer. Okay. Just off. Okay. All right, guys. How did we do on that one once we got there? Hard to graph without the actual graph. Like, it's definitely tough just on like line
I
paper.
just winged it.
Oh, you winged it. Okay. Approximating's a good thing.
Just drew some dots.
That's not great. Anybody questions like how I got the blue ones, or anybody struggling with the order with the graphing? Yeah. Sure. Yes, totally fine. Yep. Highlight the part that's the answer, a different color. I don't care. Just if you have 2 colors, make sure you like say like blue is the answer. Don't just be like, pick the one that's right. All right. Other questions on that one? Okay. Let's try the second one. All right. -4 cosine 3 theta. And we're going from 0 to pi over 2 this time. Okay, 3 theta. How many petals does the whole thing have? 3 distinct petals. How many total petals does it actually have? 6, right? Remember, it gets graphed twice. So this right here is 1/4 of the way around the circle. So I'm doing 1/4 of the 6 petals. How many will I see? 1.5. Okay.
Sorry, into 2 pies.
So
What do you
if
mean?
it said
6.28.
No, 6 petals is why I wrote 6. What are you saying?
A really fancy way of saying 6.
Oh, okay. Sorry, I wasn't.
so if it said 0 to pi, you would press the 3.
You'd see all 3. Yep, exactly. Okay, cosine, you know that first petal happens when theta is 0, right? Because we know the maximum of cosine happens at 0. But where is that going to be on the graph this time? Yeah, it's your first point is 1, 2, is over here because it's a -4. Are we okay with that? Do we see it? Okay. Then do you know at this point how to space the points after that? Like, do you see, oh, it's going to be 120 degrees between, or 2 pi over 3 in between? Are we doing okay with that? All right. So I know the other points will be here and here. Look, make sure they're spaced evenly. Okay, 0 to pi over 2, so I need the first 1.5 petals. It's cosine, so do I start out at the petal or at the pole? Petal. And remember, we're still graphing in this direction. Yes, r was negative. Theta is not negative, though, so we're still traveling this way around the circle. So I'm going to go this direction. There we go. There's your 1.5 petals.
Oh.
Yes, that way. All right, Kayla, where are you lost?
Why we went that way?
So your angles are always going, like think when we started graphing anything. A positive theta, didn't it always go this way? Like counterclockwise around the circle. So even though I'm starting over here, I'm still traveling that way. Like my circle's going in this direction. Like
That looks like the Big Dipper. like the constellation.
it
I don't know
does.
which one it is.
Otter.
Why do you say there's 6 petals?
Okay, so if I graph 0 to 2 pi, this would be 0 to pi. Pi to 2 pi is those petals again. So it's 6 petals because you repeat the 3 petals. It's not 6 different petals.
Is it after the sign one was it
So when you have the odd p-value versus the even, like this is 8 different petals, right? And this is 6 petals, but not all different. 3 distinct. Does that help? Okay. Kayla, are you okay with the direction?
Yeah,
Are you sure?
yeah.
Okay.
I was just gonna drawing it like graph, so I was gonna put it next to it instead.
Okay. Never make any sort of like turns in it, you know what I mean? Like just make sure it stays round.
Okay.
Max,
Roses, we have to
Would
like,
there be a negative on the theta?
hold on.
find houses for up here. Is it gonna be like 6 petals when it's like a 2 signs or something, or is it?
I mean, technically there are 6 petals, but like you see 3 petals. Yes. Yeah. Yeah. I won't just ask you how many petals on this. Yeah. Okay. Could theta be negative? Yes, but I'm not going to make you do that. But yes, you could graph these like going in the other direction, but no, we're not going to do negative thetas.
Okay.
Okay. All right, guys. Any homework questions before we get to the notes?
How do we do it?
Ooh, okay.
Inner loops.
The inner loops? The inner loops, okay. Do you want number 2 or do you want number 9?
Number 9.
9, I figured would be, yeah. It's just a terrible drawing, yes. And I'm sure my drawing up here isn't going to be much better, but I'll try. Okay, kind of. This is number 9. Okay. When you're looking to figure out your A and B values, how far is it from the pole to the end of that graph? 4. Okay. So I need 2 numbers that add up to 4. Really, it's -4, but we'll deal with the negatives in a little bit. So we're thinking 2 numbers that combine to give you 4. And then how long is the inner loop? 2. So the difference between those same 2 numbers needs to be 2. So what 2 numbers add up to 4 but subtract to give you 2? 3 and 1. Okay? All right, so R equals, I know the 1 has to come first for it to actually be an inner loop, right? And then we've got our 3. Everybody okay with its cosine of theta? Okay. It's all on the left side of the graph, not the right side of the graph. So what do you think is going to happen with my signs? Negative and negative. And that's it. Okay? The only way you can get all the way out here to -4 is if these are both negative. And you're going the left side of the graph. Karina first and then Paul. Really, this will be enough to tell you. Yep. Is that better, Max?
Yeah.
Okay.
You also do number 5.
I said to skip 5 and 8 because you
Oh.
don't know those yet. That's what you're learning today. So you're not alone. Lots of people were like, what?
I was like,
Skip those. Anything else?
I think, just for like 3 and 4, I can kind of like different with the, like context or like the first.
So the circles you guys will do will either be centered at the pole, so like number 4, or it will go through the pole like number 3. If you look at,
Just by the radius.
yeah, we have one somewhere. I don't remember where it went. Maybe it's on the review packet. If it's shifted off a little bit, so like let's say, like, I don't know, it looks like it's coming out to 2 over here, but then it goes like farther on this side. So even though that kind of, I mean, rough drawing here, but kind of looks like a circle, it's not centered at the pole, right? It's not a circle then, for what this is definitely convex at that point, okay? Or like to be a circle, it has to go through the pole and be centered on an axis.
Okay, so with number 3, a circle that
3 is a circle, yeah. Yep. Because remember, the convex won't go through the pole?
Right.
Okay. Without, I mean, yes, you could write an equation that would make it with shifts and things, but not with what we're doing. Anything else? Okay, notes, guys. All right, 8-5, last one we're doing here. All right, guys, R equals theta. So we graphed like R equals just a number, and that was a circle with the given radius. But now we're going to graph that R equals the angle. So it is weird. This is going to give us the graph of a spiral. It's technically the spiral of Archimedes, but we'll just call it a spiral. We are going to make a little chart for this one. Okay, when theta is 0, what will R equal?
0.
Good start. Okay, got that. All right, next one I'm going to do is pi over 4. Now, we're going to sort of approximate some decimals on this one. Let's think decimally. What is pi? Okay, roughly 3.14. What about pi over 2? 1.57, we'll call it approximately. We'll say 1.6, okay? We're just estimating. What is that going to make pi over 4? 0.8. I'll just do the 1.6, half of that. Which is 0.8.
Yeah.
That's easier, yeah, okay. So pi over 4 gives me a radius that is 0.8. Okay, I mean, technically it's pi over 4, but I don't know how to plot pi over 4. I can plot the decimal. So I go out 0.8 and then around to pi over 4. So approximately in there would be your second point. Does that make sense? See it? Let's try another one. Let's plug in pi over 2. Okay, 1.6. So I have to count out 1.6 up to pi over 2. It's a little more than halfway between 1 and 2.
Oh, yes.
You see it? Okay. Let's do pi next. You could do 3 pi over 4, but pi is 3.14, so you're going to go 3 and a little over to pi.
There'll always be a data restriction on this because when they just keep going.
Yeah, it would go forever. We're going to graph 0 to 2 pi, but otherwise it would just keep growing and yeah. All right, let's do 3 pi over 2. Close. 4.7, 4.74, something like that. You're just adding pi and pi over 2 together. Okay, so we'll say 4.7. So that here. And then what about 2 pi? 6.28. Yeah, that's like off my graph somewhere over here. Okay, so you're going to connect these in. I mean, it's going to look like a spiral. It's not the easiest thing to graph. It's like growing outward as you're tracing it.
That would be a satisfying spiral.
According to my drawings.
I know.
Kind of a wide spiral.
It is a wide spiral.
Oh, wow. It'd be better if pi was 1.
It would be.
I mean, it's close enough. You can just round.
Just round. Pi is not 1. That is
Well,
Pi would
okay,
actually
so
round to
if-
0 if you rounded
It,
If you look at
no, pi's too big to be 1. So let's make it 10.
well, no, well, if you're rounding, just go to 0 actually.
Oh my gosh, you guys are doing rounding. I don't know what you're doing.
Honestly,
Okay, that's a spiral. You need to make sure you can identify it, right? So you can recognize it when it's r equals some angle. You know that's a spiral. R equals theta. And then, I mean, you're going to graph a couple of these on your homework, but it's not going to be like a huge part of the graphing portion of your test, okay? We don't do a ton with spirals, but you do need to be able to recognize them. All right, down below. Oops. Okay, what's different about this one? R squared. So when you see R squared, you go, okay, that's a lemniscate. Lemniscate. That's how you spell it. Lemon biscuit. It just sounds kind of like a lemon biscuit. I'm sorry. I have no snacks.
You don't have any lemon
You didn't have anything on
I did not bake you any lemon biscuits. Apologies.
You did miss pi.
I did
You
miss
had
pi.
all, you run like 20 hours.
I did not. Okay, graphing these is very simple, and we aren't going to do a lot of complicated things with them. It's just going to be, can you graph the basic graph? I'm not going to ask you intervals with them. We're not going to, there's not going to be weird rotations and things. It's very basic. So look at, we've got r squared and then equals the 16 sine 2 theta. What is the square root of 16? Okay, could we say plus or minus 4?
Yeah.
Okay. That's telling you how far out your, they kind of look like petals, but it's not really a rose. It's how far out they're going to go, the length of them, the maximum. It's, yeah, it's kind of like a little infinity sign. But we need to figure out where these points go. So now we're going to look at the sine of 2 theta. And guys, it will always be 2 theta in there for a lemniscate. It won't change and be some other number of thetas for you. So we know, when does sine of 2 theta equal its maximum value of 1? When does that happen? Pi over 2. So I got to set 2 theta equal to pi over 2. You can do the plus or minus 2 pi k. You don't technically need it here, but we can do it anyway. Divide by 2. So I get theta is pi over 4 plus or minus pi.
Oh. So wouldn't it always either be on the x-axis or on the pi reports?
That's why I said these are not complicated. Don't make them complicated, okay? So I know I have to go out a distance of 4, and then I'm going to travel to the angle pi over 4. So 4 pi over 4, 1, 2, 3, 4. And then you can either think about negative 4 pi over 4, or you can just add pi to what we just did. Either way, you would end up in that third quadrant. They'll always be straight across from each other. Then you just draw this. And again, I won't ask you for intervals. It's a little weird with these because of the squaring. So it doesn't really matter how you draw this, however you want. There you go. Do not make it harder than it is. These are supposed to be easy. The lemniscates.
Oh, it's just
All right, guys, turn the page. Try to graph that one at the top there. The r squared equals 16 cosine 2 theta. It's just another graph. It's another polar graph. You could identify it, but not a major. It's not like graph these 7 spirals for me. There's just not a lot. What do you mean? Well, you can. I could put coefficients for you. Well, you're gonna find out here in a minute.
I love lemniscates.
Lemniscates. Wait. Well, it's just a big spiral. Nothing. Let's find another one.
Oh, okay. I'm like, no, it is not. Down below or on the next page. How many pages did you turn? Okay, we'll get there in a second. Like graphing tonight?
Like right there.
Oh, just the top one. And then you'll do the others real quickly afterwards. Are we good on the top one? Check with your neighbor. Do you agree? Your neighbor is useless. Wow.
That's okay. I got that, but I thought it was too simple.
I told you these are easy. Oh no!
It's still late. I'm just gonna be either like that or like.
That's what I'm saying. They are.
I
Enjoy these.
I divided the one by 2.
You're making it harder than it is. Don't do that. All right, questions on that one. R squared equals 16 cosine 2 theta. Do we see it? Okay. Try the 2 at the bottom there. More lemniscates. And stop me if you're stuck on anything. Don't hesitate to ask. It's okay.
Yes.
Talk to each other. See if you're good.
Yeah.
Where's fine always going to go?
Oh, this is 2. 2 means something.
Wait.
It does. I drew that one weird, but yes. All right, are we okay with 1 and 2? Yes. Okay, any questions on the lemniscates? Okay, turn the page. Try and graph those 2 at the top. What are they? Spirals.
Oh, wait. This is. I'm just gonna.
I think this is wrong.
Oh, this is gonna be big.
You only have to go from 0 to pi. So, otherwise, yes, we'd be in trouble. You just have a big spiral drawn all over your paper.
Just all over the next row.
Just like,
What would you if you didn't put a domain
I don't know, cry?
Wouldn't they grow next to
Well, yeah, and it would grow forever. I mean, it would just continue.
So isn't there math response how we draw it?
Why would I give you that? I would not do that.
We just think,
Well, I'll just
we don't
start
have like
the
massive.
Unless it says like plus or minus something after it, like if it was 2 theta plus 4, you'd actually do 2 times 0 plus 4, so you'd be out at 4 then. Yeah.
Our test is just gonna be on for one of those like massive sheets of paper, like one of those massive pads.
Okay, your test will be.
But it's easy. If it's just graphing that one thing, it's not that hard. If I get a calculator.
Except you wouldn't finish.
Well, no, it would be like 0 to 15 pi. It wouldn't be actually infinite. It would just be. I don't think you'll graph 7.
You're also really humble, man.
Okay.
How do you feel about that? You got absolutely destroyed.
Do you think Carl? You think Mary Somerville
I think Jesus
was humble? Do you think she was humble?
I guarantee you she was.
She was not. I guarantee you stuck up.
Yes.
Oh gosh, I got Leonardo in my DMs.
Okay.
Oh, it's negative.
It does change it a bit.
Everything wrong except for being
Okay.
Like I like best.
I know you used that one.
All right, guys, let me put them up here. So number 3, when you plug 0 in, it's still 0. When I plug pi over 4 in, it's like I get pi over 2 as my answer. So I get the 1.6 out of it, but you're still only graphing it at the pi over 4 angle, okay? Pi over 2 is going to give me 3.14. I'm just going to go all the way to pi now. Pi is going to give me 6.28, so somewhere way out here. So it's just like a growing spiral. Yes. Okay, we all right with that one? Second one, you do have a negative. I'll write the little table this time just in case. 0 is still 0. Okay, so when I do pi over 4, what do you think I'm going to get for the r out of that one this time? Negative what? 0.4. Okay, so think about how you'd graph that. You go negative 0.4 and then the angle of pi over 4. So you're in the third quadrant. Kind of in there. Right? Okay, then I'll do pi over 2. What am I going to get for these? R for pi over 2.
You know when you do that?
Yeah, it'd be negative 0.8. So down there, sort of, almost to 1. Hey, guys. All right, I'm going to go right to pi next. What will I get for pi? Negative 1.6. So you go left 1.6 and then around pi. So that takes you over there. So you've got this like small little spiral. Questions on that one? It's fine. Okay. Everybody good on the graphs for today so far? Yes. Yep.
Some of this technology doesn't.
All right, guys. This is the trickier part of today at the bottom here. We're skipping number 1 because it's uglier than it needs to be. So we're going to start on number 2. It says find where the polar graphs intersect on this given interval. So do you guys remember in Algebra 2 where you solve systems of equations and you're looking for that intersection? Okay. Yeah, you could do substitution, you could do graphically, you did elimination. Elimination doesn't really work here. Like if you had you could take this one times 5 and add them together. You'd eliminate your y values. Do you not remember that? Wait, what? Who does not know how to use elimination? Did you not do this in Algebra 2?
Obviously that. Oh, obviously theta is that theta half.
Oh, it takes way too long.
What is that?
Okay, let's do it again. All right, I didn't know you guys didn't know that. How do you not know that? Okay, I will just make one up here.
Is that something we need to know?
Yes.
Oh.
Okay. Because let's say, what if I made this like complicated and didn't...
Oh, they did this example.
So there's my 2 equations. Do you really want to solve one of those for x or y and then substitute it in? Like, that'll be ugly, right?
Yeah, but
That's how you do it.
No, that is not how you do it.
Or you just plug it in yourself.
No. Oh my goodness. Okay. We're gonna do.
Have ever heard of it.
What?
I've never heard of it.
This is like ever. Yeah, it
Dude, yeah. Oh my gosh.
I don't know.
Okay, let me show you then. So to eliminate the variables, you need to make the coefficients essentially match on either the x or the y, but you want opposite signs. So which is going to be easier to make match, the x or the y? The x. What am I going to take this equation times? And I'm going to do -2, so then I get opposite signs. Okay, so I'll rewrite the first one. And then this one will become -4x plus 6y equals what, -40? Then if you add the equations together, what happens to the x's?
Why do you have?
They are eliminated. What?
Can you do that?
Yeah.
What?
Why not?
Wait. How did you?
Yeah, like substitution is just,
How did you go
Well, you
from
plug it in.
that? How did you go from that second
the left side to the right. So the top equation stayed the same, right? The bottom one, I multiplied everything by -2.
It's 30 over 30.
I was rustling.
Oh, okay.
You see it? Okay, so y, I made this up, so it's this ugly negative 30 over 13. So that's the y part of the coordinate. How would you find the x? Plug it in, and you can plug it into any of the equations. It doesn't matter which one. And then solve for x.
So you need to have opposite signs that you can add. As long as, wow. That's like blue and white. I never knew that was a thing.
That is
I
a
don't
thing.
take the two out of the first.
I didn't take it out. I just picked, what am I going to multiply by? Because I was trying to make these guys match, essentially.
I know.
Let's try another one, guys. Let's say, and I'll probably make ugly numbers again, so sorry.
What if we already solved?
Oh, we'll go 8. I know that's very basic, but
Wait, so would you?
what would I multiply by this time? And which equation would I multiply?
Well, this one, I would just substitute. You divide the top one by 3. And now you It's still easier than whatever this is.
Yeah, so, okay, so here's the top one. I would take this times 2. So 4x plus 4y equals 16. Add them together. 7x. What happens to the y's? Okay, and what do I have here? 28. Look at that. I made a good one, guys. What's x equal? Okay.
Oh, okay, I get it.
And then what do I do with that 4? Plug it in anywhere. So this one looks the easiest to me. So I'm going to do 2 times 4 plus 2y equals 8. What do I get? 0. So your answer is the point 4, 0. Okay. Yes, guys, file that away. You need that side tangent for us in the lesson today. But
Oh, wait.
Did the screen light turn pink?
that probably happens. Yes, I need a new VGA cable, and I can tell I need that because it like flashes text.
Wait, so in neutral essentially you get points, or what do you do?
You will get points as your answers. Yes.
Is the first one actually?
Stop. Just wait. There's a lot I have to tell you about this. Okay. Hold on. Okay. You have to do this algebraically, but you also need to think about what the graphs look like to make sure you don't miss any solutions from just doing the algebraic way of solving it. Okay, so the first one, I can certainly just set the 2 equations equal. So I'd have 2 equals secant of theta. Do we agree that that's the same as 1/2 equals cosine theta? You with me there? Kate's like, oh, I should write. So what are my thetas going to be? Pi over 3, and what else? Okay, I like it. That's not the whole thing, though, okay? Like we gave an XY ordered pair in the other one, we need to give an R theta answer. Yes, you can easily see in this one that R is 2, or you could plug the pi over 3 in to get the 2 as well. You'd do pi over 3 and you'd plug in 5 pi over 3. What do you mean? Okay. So you've got these 2 answers, 2 pi over 3 and 2 5 pi over 3. Either plugging the theta value, like the pi over 3, back into the equation, or this one, they kindly just tell us R equals 2. Okay. Now, we want to double check to make sure there aren't more solutions that we didn't just find by doing this way. So let me just sketch. What is R equals 2? Circle.
Yeah.
Yep. The other one is, yes. So that's a circle with a radius of 2. Kind of. All right, and then R equals secant of theta. What is that? Yes, where is it? At 1, okay. All right, so we can easily see there are two intersections. Failed the vertical line test.
Oh.
It's okay. I like that you're throwing back to functions. Good job.
It is the vertical.
It is the vertical line test. There you go. So what you have to be careful of, this kind of circle where it's centered at the pole, 0 to 2 pi, it only occurs once, right? But do you guys remember what happens? Let's say it's r equals 2 cosine theta. That's a circle over here with a radius of, sorry, a diameter of 2. But if I graph from 0 to 2 pi, what happens? Yeah, it repeats, so you get extra answers. And I realize I'm helping you out with number 3 yet, but so you got to be careful, because you might have more answers than you realize you have. But there are just 2 answers to number 2.
So do you include K then?
No, you just have to think.
Yeah, it's okay.
Yeah.
For all the blue ones that are opposite sided,
Yes.
you can set it on the whole.
Correct. Yep.
Oh yeah, because I guess it's only in half of the thing. Yeah, that makes sense.
Okay. All right, so try number 3 for me. See what you can find. And guys, we're only doing 3 and 4 on the notes, and then we're stopping.
Yeah.
Okay.
No, no.
Wait, no, it's not. Oh, wait, there's one answer.
No,
No, there's one from varying people.
It's just a shrug for now. You keep working it out. I'll tell you more in a bit. Keep thinking. Make a sketch if you're not sure. There are some very furrowed brows happening. Okay.
Oh,
2 answers.
Oh, yeah, no, this.
there's 4.
I would. It's
No, that's. Wait, is that 4 and then 30?
9 pi over 3 is.
Too big. You can only go up to 2 pi. Your thetas have to be between 0 and 2 pi.
Yeah, no, there's 2 answers.
Wait, but it's 0 to 2 pi.
Yeah, the theta isn't negative.
Oh, this is why we did that thing.
What's that?
The thing,
You know, that thing back from 8-1 that we did.
yeah, that thing.
That thing.
Back
Yeah.
from 8-1.
Yes, I do want you to like remember the whole meaning. I know. We're working. I'll go over it in a minute, but I want you to keep talking. Keep thinking.
Oh, no, it is 4.
That's like they're on.
Yeah.
Oh, and one? Yes.
You can do 1.
Yo, you could have done the same thing up there. It's the same point, though. You can find different ways to write the same point. We don't need to do that.
Wait, is
do?
cosecant 1 over sine and 1 over
Why? That's so stupid.
Yeah, couldn't we have written it a different way up there?
Yeah.
Is cosecant 1 over sine?
Wait, but so why do we need to write it a different way?
It's like, isn't there 4 solutions for the first one? First one, 2?
No, because the circle doesn't go around twice. The reason you have to find those other ones is because the circle actually happens twice. This circle only happens once.
Negative, yeah.
Wait, does the r equal 2 cosine theta happen twice?
Just what? The r equals 2 cosine theta is the one that happens twice. Yeah.
This R is because it's.
I'll explain, I promise.
Is the circle in the middle or off to the side?
Yes. There's 2 circles. One's in the middle and one's off to the side.
Why is one off to the side?
2 cosine theta. Isn't that this guy up here? That's the one I drew right about.
Oh yeah, that is how two circles work.
Wait, Mr. Can you say what you just said? Like that?
Yeah, sure. So this is a circle off to the side. That's what I've drawn up there. This is a circle centered at the pole with a radius of 1.
Oh, I get it.
Okay.
Now I can't find the points in my head.
Wait, but then there would still be only 2 answers.
No, because that
I'll explain.
Oh.
But it just doesn't work.
I know.
Wait,
We'll get
is that in there?
Can we work on reports? Or
Yeah.
You just do it hard, so you make.
It doesn't matter how many times the circle is done, it's still the same thing.
Okay, so let me trace it in purple. How many times does my purple circle intersect the blue circle? 1, 2, 3, 4. Like here, I'll do it. Okay, ready? Can you see Bennett?
Wait,
Stand up and go on.
Okay, can you move for a second?
sorry.
You're okay. So as I have to go around twice, right? So 1 intersection, 2 intersections, 3 intersections,
Why do you have to go around
4 intersections. Because if I actually grab, oh, here it is, this one. 2 cosine theta. This was way back, 8-2. All right, look at 0, I get 0, right?
Oh, it only goes to pi, and then you have to do it twice.
Yeah, but if you're giving polar coordinates, they're overlapping the same polar coordinates.
You have to tell me how many times does it intersect. Imagine there's like a little person running around on the circle.
Yeah.
Like, they're paying a toll at each of these. They have to do that 4 times. Okay. So, to go around twice 6. So 0 gives me 0. Let's do, I don't want to do pi over 4. Let's do, sorry, that gives me 2, not 0. Do pi over 2. What do I get?
Yes.
So I've done from here to here so far.
Oh, so let's go right back and then okay.
Okay. Which part? Well, how much of this circle do I see by only going to pi over 2?
Yeah, since it's in.
That's half,
I think so. Yeah.
right? So if I go to pi,
No, I know what you mean, and I think so, but
what do I get for pi?
Oh,
-2. So that'd be back here, like I go this part. So by the time I get to pi, you've
I
seen
see this work.
So if I graph all the way from 0 to 2, I see the same circle.
So would you have to move to negative 1 or
Root 2 over 2 equals 6.
okay.
Well, let's just like with the roses, when it was an odd value. Like, let's say it was 3 theta. Then you all 3 petals. Then technically we're at 6 petals because we traced over the 6. It's that same idea. This is technically a 1 petal rose. Okay. Guys, if it helps you, this circle off to the side, that's a rose with 1 petal. Okay, B value's odd, you trace it twice. Same thing. Okay, good. I'm gonna go. Yeah, I'm gonna check. All right, guys, let me go through it. So algebraically, you can do 2 cosine theta equals 1. So I get cosine theta equals 1/2. And same as our last problem, that's pi over 3 and 5 pi over 3. We're okay with that? Okay. What does r equal when theta is pi over 3 or 5 pi over 3?
Hey, could there be 8 answers for number 4?
I think there's just 4 on that one, but we'll look at it. Guys, what is r when theta is pi over 3 or 5 pi over 3? 1.
Wait,
Okay.
what?
We're on number 3 here. Okay, and that makes sense. 1 pi over 3 was up there. 1 5 pi over 3 is down there. But that's only giving you 2 of the answers. So you have to think back, what are other ways that I could name that point with my theta still being between 0 and 2 pi? Did you say 2 pi over 3? Okay, and -1. Okay. Yes. Your test is not like there's only one of these on your test, and it's not terrible. Your homework, I think you're number 7. I think it has 7 answers, so you know a good bit. But the test is easier than these. Yes. Why couldn't -5 pi over 3 be 1? Because theta has to be between 0 and 2 pi. That's what it says up here. Right? So you can't use the negative angles. You're right that that's in the same spot, but that doesn't fall in. Okay. All right. Try number 4 for me. I think we're getting 4 answers, but let me see what you got here. What did you do?
Plus or minus root 2 over 2. You substitute plus or minus root 2 over 2, sorry. And you get plus or minus root 2.
Okay.
R.
Yes.
So then you put that with all of these.
No, because that you have to figure out with a pi over 4, do you get a positive root 2 or a negative root 2?
Oh,
Don't get close.
Okay.
Because if I plug in pi over 4 here,
Oh, okay. So you have to do that with each individual one?
yeah.
I can just do it in my
Think
head,
through it,
but
yeah.
like, yeah. Okay.
Yes.
Yeah.
Okay. We're there. Please explain.
You got plus or minus root 2 over 2 for R?
Yeah.
But like you go, if you just put in pi over 4, you're going to get 1 answer. So sine for pi over 4, what is sine? Sine pi over root 2, so it's just positive root 2 for this, positive root 2 for this, with negative root 2 for this. It's, you have to like substitute.
That helps you see all 4 of them.
Like they're all going to be root 2, but to find whether they're positive or negative, you can either think it through or you can just.
So divided by 2. Yes.
Okay. Can we do that for the back?
Yeah.
I mean, you can try, but they're really messy. They're like super complicated.
Okay.
I would not. I'm stopping after this one.
Are we don't have to do that?
No, this is the last one we're doing.
Oh, cool.
Yeah. How we doing, guys? Are you getting 4 answers? Oh, okay.
We're not actually getting out of the accurate.
Okay.
Wait, it's not 5. How is square root of 10?
Well, it's going to be more than square root of 9, right?
Or like less than 5.
How about less than 4? closer to 3 than 4.
I thought that was a positive for the line test a couple minutes ago.
It's true. Oh, yes, it's been a day.
Oh no, we cannot do the thing. So the cosecant.
Coming here from chemistry is just a really bad idea.
That's a lot, yeah.
Where I come from,
Yeah. Where do you come from?
Miss G, she's like the scary English teacher that everyone is afraid of.
Oh, goodness.
It's a mental journey.
Mental journey.
How do you add 2?
It is, yeah, it's a little ugly.
We're so done. Yeah, we're gonna be 2. That's gonna help us.
How are you getting 1/4?
Oh.
1.8.
I got
3.6.
The square root of 2 was 4. It's okay.
how do you find the radius?
Okay. Guys, are we okay with the thetas being all that over 4s? Do we get that part? Yes. Okay. How do I find r from that? You plug it in. You can either plug it into the cosecant one or the sine equation. I'm thinking most of you will pick the sine equation. So what is the sine of pi over 4? Root 2/2 times 2. Okay. So you are just thinking through, is it going to end up being positive or negative root 2 depending on the angle? So pi over 4 is positive. What about 3 pi over 4?
It's not root 2 or root 2 over 2.
So when you plug it in right here.
Oh, yeah.
Yeah? Okay. So yes, it's root. So what will it be at 3 pi over 4? Yes, root 2. What does that mean? It's going to be at 5 pi over 4 and 7 pi over 4. Negative. And those are your 4 answers. And again, you can think about what these graphs are. So r equals 2 sine theta. That's up here, right?
This is my spot.
And then r equals cosecant theta. That's just y equals 1. So it looks like 2 intersections, but because it goes around twice, you know you get all 4 of those intersecting points. Okay? Questions? Taylor, you look like your head hurts. You got it? Okay.
I was looking at the homework.
Oh, you're going to skip a couple of the homework ones. So,
Hold on.
Right, yeah.
that's the end of notes. We're not doing those last few examples. So. Yep, 1 sec. Guys, skip 5 and 6. So you're only going to do 1 solving, 1 on the back. And even it's kind of tricky, but do the best you can. All right. You wanted those, Finn? Yes. Okay. Skip 5 and 6. Like I'm not missing it this time. What am I skipping? On the homework.
Oh,
Yeah, sorry. We're done with notes, guys. Moving on.
wait, that doesn't make sense. I think